How is everybody? हाँ क्यों नहीं चला है?
चालू तो है बट
एसी चालू है और अभी चालू किया रहेगा शायद से. Okay, where did we stop last lecture? Where did we stop last lecture? नहीं यार, तूने तो अच्छे सवाल किए थे लास्ट क्लास में. क्या पूछा था? उसको सवाल किया था उसने, how to measure velocity of light.
नहीं लाइट का स्पीड
वही
कैसे किया कौन से
you delusional.
अरे हाँ
कैसे बोल सकते हो भाई? मैंने बोला था कि you search on the net and
कोई तो साइंटिस्ट ने किया था
occult. There are many scientists who have done it. The last one जो most credible है वो occult. FOCAULT or something. तो तू ऐसी curiosity में question कर लिया फिर बाद में you did not explore. What were we doing? Anybody tell me? हो गया था? How's your hand now? You are able to completely flexible now?
वैसे तो दो ही 3 4 5 है concept of absolute refractive index.
Okay, वहाँ तक किया था. ठीक है चलो. Just we're done factors affecting refractive index and all.
अभी दोनों सब साइड है दोनों साइड है
Okay. So also refer your book. When here, see a few things missing. So what was refractive index? How did we define refractive index?
is the ratio of the velocity of
So this was the first definition of refractive index given by Snell's law, right? So how do you read it? How do you read this?
second medium to first
Yes, refractive index of second medium with respect to first medium. What is second medium? Okay, boys, attention here. What is second medium? Second medium is the refracting medium. First medium is the incident medium. Okay, that's why it is also written as 1 mu 2. Sometimes to avoid confusion. Okay, it is also written like this. First medium is incident medium. This is refracting medium. Both are read the same way. How do you read it? Refractive index of second medium with respect to first medium. So first medium is the original direction, incident ray. Second is where the direction changes. This is very important that you should understand this. Okay? It is always the refractive index of the second medium, meaning where the direction changes. Now, so this is the first formula. What was the second formula for refractive index? It is also defined as this. Did I give you this formula? Ratio of speed of light in the first medium to the speed of light in the second medium. This is V1 and V2. Then third is concept of absolute refractive index. What is absolute RI?
when the first medium is here.
Yes. So absolute RI is written as this. When the first medium is air, you don't mention the first medium. Understood? you do not mention the first medium. Okay. So fourth, relation between. So then, if this is absolute relative index, refractive index, and what is this? This is called relative refractive index. Okay. So let's write on relation between absolute and relative refractive index. So what is mu21? Mu21 is equal to V1 divided by V2. Right? What is mu21? V1 divided by V2. Here what is V1? Speed of light in the first medium. Speed of light in the second medium. Now we can multiply and divide by C. So this is C by C into V1 by V2. We can do this. Correct? We can rearrange it further. That is mu21 is equal to, what is mu21? Relative refractive index. Refractive index between two mediums. So this becomes C by V2 1 by C by V1. Can we do this? Okay. So can we write C by V2 as mu2? Right? Divided by C by V1 as mu1. So this is the relation between relative refractive index and absolute refractive index. So example क्या होगा इसका? Mu glass with respect to water will be equal to mu g upon mu w. Where what is mu g? C by Vg, and mu water is C by mu w, Vw. Where one of the lines is not working, right? Sorry, AC is not working. AC के बारे में सोच मत भाई, ये तो बैठना मुश्किल हो जाएगा, इसको बोल देता हूँ। वो लाया था क्या रिमोट? I've kept it on 24 now. Let us see what happens. Somebody knows how to just check if the mode is correct. Just check the mode. Any damage caused, the bill will be sent to you. Okay.
तो डोर बंद कर दीजिए।
चल रहा है अभी?
आवाज
बाहर से आ रहा है।
नेक्स्ट रिवर्स
आ रहा है? ठीक है चलो। This is after he did something or? False claims. C by VW. Is this clear? What is it? Suppose these two mediums are glass and water. Then what are their absolute refractive index? Refractive index of glass with respect to air. Refractive index of water with respect to air. Then the relation between the absolute refractive index and the relative refractive index is given like this. Clear? So this is the relation. Then you have this is it. And there was, did we discuss principle of reversibility of light? So the fifth expression is reversibility of light. We did that, right? That's what. So this also we discussed, like mu21 is equal to sin I by sin R. This is equal to 1 by sin R by sin I. This is equal to 1 by mu12 like this. Correct? By reversibility of light. If we change the direction of light, like instead of air to glass, for the same path, okay, light will go through the same path if we change the direction. We have done that, I think, in the first class. So then mu21, therefore mu21 is equal to 1 by mu12. So these 5 relations are useful relations related to refractive index. Okay. So how do you read this? Read this relation.
Speed of light.
Wait.
mu21 is equal to.
You don't read it as mu21. How do you read it? The refractive index of second medium with respect to first medium is equal to reciprocal of
Refractive index of first medium to refractive index of second medium.
So what is the difference between mu21 and mu12? In mu21, light is traveling from air to glass. Means first medium to second medium. Here it is traveling from second medium to first medium. Like, to illustrate this, so this is the first medium and this is the second medium. When you apply Snell's law at point O in this direction, 1 to 2, then at O, you have mu21 is equal to sin I by sin R. mu21. Now imagine you apply Snell's law in this direction. Because by path of reversibility of light, principle of reversibility of light, the same path will be followed. So now you apply Snell's law for this second case. So it will be now mu12. What is the second medium now? The first becomes second medium when the direction is changed. Now what is angle of incidence in this case? The angle of refraction is sin. Okay. So this is the relation.
C is speed of light in air है ना,
Yes.
तो उसमें हम लोग ने C1 multiply करा है कि इससे velocity का वो ratio होता है.
So that we get the absolute half. क्योंकि हमको इसको कन्वर्ट करना है, रिलेशन निकालना है रिलेटिव रिफ्रैक्टिव इंडेक्स का दोनों मीडियम के एब्सोल्यूट रिफ्रैक्टिव इंडेक्स के साथ. ठीक है?
So GW
Glass water. So G stands for glass. There are only 3 transparent mediums that numericals will be asked. Okay, on water, air, and glass.
So why didn't we represent GW as 1, 2, like any normal medium?
We do represent 1, 2.
Then why did you write it differently?
Because in numericals you will get it like this. It is not necessary that always the suffix will be in terms of number. It could be on the first letter of the medium name.
And so we first read it from right to left or left to right, like from respective to water to glass or glass to water.
You tell me. What is it? Is it water to glass or glass to water?
Glass. Water to glass.
Water to glass. That's why to avoid that confusion, we follow this also. So यहाँ पे क्या हो गया?
1.
It is written as 2, 1. So where the light is going from? 1 to 2. Either it is written like this or like this. Both are read the same way. Refractive index of second medium with respect to first. Refractive index is always of the medium where the direction is changing. One medium to other medium. That's when refraction takes place, right? Where refraction takes place? In the second medium, always. So it depends from where the light is traveling from, 1 to 2 or 2 to 1. And then they are related also. This expression relates that. Okay?
So we'll give it the question from where.
Okay? So when you do numericals and use these formulas, that's when it will become clear. Is it? So this is all. This is the only thing to be understood in this chapter, really. Rest is just extension on this. Okay?
So very big chunk.
Yeah, kind of. But not bigger than the experimental setup to find the speed of light. Okay. So are we good till here? Somebody give me the book. Okay. So next topic is conditions for a light ray to pass undeviated. Anybody has any queries here? So we'll take it up when we solve numericals. Okay. Right now you just write this. This is the most important thing in this chapter. Okay. Anybody writing this part? This we have just done multiplication. यहाँ पे लिख सकते हो region. Multiply and divide by C. C is speed of light. Wherever you see C in optics, it is speed of light. Okay. Now next is, so I would want everybody to be with me. Anybody who has not yet completed, first complete it. Then I'll begin the next explanation, which is about conditions for light ray to pass undeviated on refraction. Did we discuss this? It was all about temperature setting up. 24 is good. Alright, switch off. 24. So tell me, when will the ray not be deviated?
So when the incident is normal to the 90 degree.
When the incident is normal to the 90 degree, what do you mean?
90 degrees is normal.
Again the same thing you are saying.
90 degrees is normal.
Along the normal. When the ray is along the normal, so it's not 90. I is 0 then. Because I is the angle with respect to normal. Okay? So when the incident ray is along the normal, then it passes undeviated. So this is the first condition. When Angle of incidence is equal to 0. Okay, whenever any challenge with English, use mathematics. Angle I equal to 0. That is when ray is incident along the norm. When the ray is incident along the norm. Next is when will it not deviate? When there will be no bending. When the refractive index are same for both, right? So Ri of both mediums are same. In this case, there will be no deviation. So this is mu1, this is mu2. So that is when mu1 is equal to. So this is kind of a hypothetical case. How can you make both mediums same? Like air to air, that means there is no change. Okay. Right? This is on page 78. Okay. You writing this? So anybody, any difficulty, please stop me and ask. Okay, then let's discuss factors that affect Ri. So what affects the refractive index? Optical density, temperature, wavelength. But how? What happens if you increase the temperature of the medium? Its optical density will increase or decrease? Decrease. Because on temperature the medium will expand. Okay, so abstraction reduces, right? So you can see the nature of the medium. So nature of the medium means the optical density. Less the speed of light in a medium as compared to that in air. Right?
The nature of the medium means different.
Optical density.
Different mediums, air, water, like that. Right?
Obviously, air is one reference. The refractive index is calculated with respect to air. That's what is the absolute refractive index. No. What is absolute refractive index? It is the refractive index of the medium. So you have to have some reference. So the reference medium is air. That's where the speed of light is maximum. Air and vacuum is treated as one medium. So our reference medium is air or vacuum. All other substances, the refractive index will be greater than 1. Whenever the refractive index is greater than 1, it means the speed of light will be less than the speed of light in air. Okay? That is when only it will happen, no? Therefore, how do you define this? When will this be greater than 1? Only when Vm is less than C. Only then it will be greater than 1, no? Understood? So, except air has highest speed, C. In all other medium other than air, V has to be less than C. वही तो है, कभी तो mu will be greater than 1. तुम्हारे बुक में जो टेबल है देखो, there is a table on page 78. There are so many mediums given. Except air and vacuum, all other mediums have refractive indices greater than 1. Can you see the table? Except air, every other medium has refractive index greater than 1. ठीक है? So that is their absolute refractive index. Every substance's refractive index is its absolute refractive index. Okay. All right. So the factor on which it depends is, one is nature of the medium. Because different mediums have different speeds of light. So that will decide what is the refractive index. EM will be different medium to medium. Right? Okay. So VM will be always less than C and will be different from medium to medium. Okay, that's why you'll have different refractive index for different mediums. Right? Next, it will also depend on temperature. Second factor that affects mu is inversely proportional to temperature. Okay. So when the temperature rises, refractive index decreases. That is, with rise in temperature, so what is the meaning of decrease in mu m? Decrease in mu m means the speed in the medium is increasing. That's how this will become closer to 1 now. It will not be greater than 1. It will become closer to 1. Are you getting it? So this formula is important. This reduces when the denominator increases. So with temperature, the optical density reduces. So the speed in the medium increases. Therefore, this decreases. Now let us see what happens to the wavelength. Wavelength will also have the same relation. Right? Since velocity is equal to f lambda, this means wavelength is proportional to, or speed is proportional to wavelength. There is a direct proportionality between speed and wavelength. Right? So, did we discuss that the frequency does not change when light enters from one medium to other? Okay, so we need that concept. Anyway, so what is refractive index of medium? You know this, right? And so this will be what? Whenever light enters from one medium to other, okay, the frequency does not change. Because frequency depends on source of light. If the light is coming closer to the normal, it means the speed has slowed down. Correct? It is a denser medium. It is entering a optically denser medium. So it is slowed down. So bending towards normal. Now what is V1? If frequency does not change, it will be f lambda 1 divided by f lambda 2. Correct? F does not change during refraction. This is a fundamental. Because frequency depends on the source. The source which is producing the light. What is the light source? In the lab, it could be electric bulb. So let us say it is a sodium lamp. So it will produce a yellow light. So it will give that many cycles per second, no? Whatever source is producing light. So source is producing light with a fixed frequency. But when that light enters into a different medium, only its speed changes, not the frequency. Like, let us say the light entered from here to here. यहाँ पे it was having a bigger wavelength. Okay. When it entered here, it now is traveling like this. So 2 cycles here, but now 2 cycles with a so frequency does not change. Okay. Whatever time was taken to complete 2 cycles here, the time is same. In the same time, the same wave travels here. So now the wavelength has reduced. Okay. Is that clear? So then what happens? So mu21 is equal to lambda 1 upon lambda 2. So what is the relation between, if this is air, right? If this was air, then this becomes constant, right? So this means mu2 is inversely proportional to the wavelength in the medium. mu2 is the property of medium and the wavelength of light in the medium. So what is the relation between the refractive index and the wavelength of light in the medium? There is an inverse relation. Okay. So which is like this. So whenever the wavelength will be less, whenever wavelength increases, the refractive index decreases. That is Ri of the medium decreases with rising wavelength.
So changing wavelength is responsible for changing color.
Yes. So wavelength means color of light. Wavelength is the subjective property of color of light.
So then what does frequency? Frequency, what does it do?
Every wave has characteristic. Wave has a speed, it has frequency as well as wavelength.
But changing frequency, how do we observe it?
You cannot observe change in frequency during the radiation. You can observe change in frequency like we are all, let's say, human, right? But everybody's sound is unique.
Sound का I know, light
Sound is
light को कैसे affect करता है?
light में frequency ऐसे affect करता है like C is equal to F into lambda. So this product will be same always. Okay, so if you go from Vibgyor like this, so if you go from left to right, violet to red, the wavelength increases. Okay. So this is so the frequency decreases. So 4000 angstrom to 8000 angstrom. The product remains constant, C. So as you go from here to here, the wavelength increases and frequency decreases in the same proportion. But here we are talking about a monochromatic light. The light color remains same. So frequency still is same. But now what is reduced is speed. So speed is reduced due to reduction in wavelength.
That's why lambda has to be.
Yes. Okay. So only speed is affected, not the frequency.
So, but if lambda is affected, frequency is equal to C by lambda or etc.
Yes, you can.
But if lambda is affected, then frequency की value change हो जाएगी.
कैसे?
ना आपने तो
For the same light. For the same light.
For different mediums. नहीं होगा.
Different medium में भी तो lambda ही change होगा ना, frequency थोड़ी change.
but अगर वो change होगा तो frequency भी फिर change हो जाएगी ना.
कैसे?
तो अगर lambda मेरे को idea नहीं lambda का value क्या होगा, but
नहीं मैं दे रहा हूँ तुमको lambda का वैल्यू. ये है समझो 4000 है. ठीक है. तो ये 4000 नहीं होगा, उससे कम हो जाएगा.
तो सर अभी जैसे वो फॉर्मूला डिराइव किया कि C by lambda is equal to F frequency. तो अगर C की तो वैल्यू कांस्टेंट है.
C की वैल्यू कहाँ कांस्टेंट है? C V हो गया ना यहाँ पे. C कैसे कांस्टेंट है भाई? C अभी F कांस्टेंट है तो C is proportional to lambda है. वो C नहीं बोलेंगे तो उसको क्या बोलेंगे? V. C केवल वैक्यूम में बोलेंगे. यही तो फंडा है. सारा चक्रम यहाँ पे है. मीडियम में C नहीं बोलते उसको.
फिर सर आप C लिखा था
C यहाँ पे एक कलर के लिए.
ठीक है.
एक कलर के लिए. तो C यहाँ पे है ना मीडियम 1 में. तब से तो वही बोल रहे हैं भाई C by V वही तो चल. नहीं ठीक है. तो मीडियम 1 अगर एयर है और मीडियम 2 अगर ये मीडियम है तो वैसा. ठीक है. सबको समझ आया? तो ये धीरे धीरे क्लियर होगा. बुक में जो इसने लैम्डा डैश इक्वल टू लैम्डा बाई म्यू किया हुआ है, वो जो ऊपर वाला लैम्डा है वो वैक्यूम का लैम्डा है जो हमने यहाँ पे किया. ये वैक्यूम का है. वो तो कांस्टेंट ही है ना वैक्यूम का. ठीक है. इसके लिए हमने दोनों मीडियम एंड इनसाइड मीडियम जो वेवलेंथ है उसका रिलेशन निकालना है. तो देयर इज अ इनवर्स रिलेशन. इज दैट क्लियर? देखो वो कैसे है मैं बताता हूँ. सी ये चीज तुम्हारी क्या थी? ये चीज तुम्हारी थी सी. ठीक है. अगर फर्स्ट मीडियम तुम्हारा एयर है तो ये सी हो जाएगा. ठीक है. और जो सी में फ्रीक्वेंसी थी, लेट्स से ये रेड कलर लिया, रेड या कोई भी एक कलर ले लो, कोई एक कलर ले लो. तो एक कलर का जो फ्रीक्वेंसी हो तो फिक्स ही होगा. तो ये फ्रीक्वेंसी तो चेंज नहीं हुआ ना, तो कांस्टेंट ही हुआ. ये पूरा चीज क्या हो गया? कांस्टेंट. तो μ21 is equal to constant by lambda 2. मतलब μ2 is proportional to 1 by lambda 2. ये क्या आएगा फिर? तुम कंफ्यूज इसलिए हो गए कि मैंने 1 को हटा दिया. मतलब ये क्या हो गया? एब्सोल्यूट रिफ्रैक्शन. तो ये कांस्टेंट हो गया ना. C by F कांस्टेंट हो गया पूरा. C तो कांस्टेंट था ही, F भी कांस्टेंट है. ये पूरी चीज कांस्टेंट हो गई. मतलब क्या मिला हमको?
1 by lambda
प्रोपोर्शनल टू 1 by lambda 2. कांस्टेंट निकालोगे तो प्रोपोर्शनल आ जाएगा ना साइन. बस ये. ठीक है. सो दिस इज व्हाट इट इज. सो वेवलेंथ रिप्रेजेंट्स कलर ऑफ लाइट. तो इसका मतलब क्या हुआ? कौन सा कलर का लाइट ज्यादा बेंड होगा और कौन सा कलर का लाइट कम बेंड होगा। मैक्सिमम वेवलेंथ किसका है? रेड कलर का। तो कौन सा वाला, जब वेवलेंथ ज्यादा होगा तो रिफ्रैक्टिव इंडेक्स क्या हो जाएगा? रिड्यूस हो जाएगा। तो रेड कलर कितना ज्यादा बेंड होगा या कम होगा? कम बेंड होगा। मतलब रेड का जो स्पीड होगा वो ज्यादा होगा इसके अंदर। मीडियम सेम ही है लेकिन कलर चेंज हो गया। वॉयलेट ज्यादा स्लो होगा, मतलब वो नॉर्मल की तरफ ज्यादा जाएगा और रेड नॉर्मल की तरफ कम जाएगा। रेड कम बेंड हुआ, वॉयलेट मैक्सिमम बेंड। समझ में आया? ठीक है, ये कॉन्सेप्ट है, बस इसको कैच कर लो।
सर रेड का 8000 एक्चुअली होता है क्या? और वायलेट का 4000।
मतलब 8000 प्लस माइनस, एग्जैक्ट 8000 नहीं, वो बैंड आता है ना। रेड जब स्पेक्ट्रम देखोगे तो इट्स नॉट अ सिंगल लाइन, इट्स अ बैंड। तो इट्स अ रेंज प्लस माइनस 1000 ले सकते हो आगे पीछे, या प्लस माइनस 500। ओके, सो अब तुम्हें 2-3 रिफ्रैक्टिव इंडेक्स भी दिमाग में होने चाहिए। आर वी गुड टिल हियर? Have I given too much detail or are you able to absorb it? हाँ, अभी बुक पढ़ोगे तो समझ आएगा, नहीं तो ये वाला जो चीज है ना, सिर्फ वेवलेंथ चेंज हो रहा है, फ्रीक्वेंसी चेंज नहीं हो रहा है। The number of cycles per second is same. That's frequency. So what I've written is जितने टाइम में इतना डिस्टेंस कवर कर रहा है, सेम टाइम में कम डिस्टेंस कवर करेगा क्योंकि वेवलेंथ थी छोटी हो। ठीक है, okay, next is so what did we cover? We discussed what are the factors that affect the refractive index. Okay. Next is reversibility of light. We have already discussed. Next is experimental verification of Snell's law.
एग्जाम में नहीं पूछेंगे
क्या चीज?
एक्सपेरिमेंटल वेरिफिकेशन ऑफ लॉज ऑफ रिफ्रैक्शन
पूछ सकते हैं। And determination of refractive index. ये जितना डरावना लग रहा है उतना डरावना है नहीं एक्चुअली। तुमने ट्रिग्नोमेट्री पढ़ी हुई है ना? सो यू आर फैमिलियर विद sin थीटा। क्या होता है sin थीटा?
अपोजिट, अच्छा
ये वाला
अपोजिट अपॉन हाइपोटेनस, अपोजिट अपॉन हाइपोटेनस। ठीक है, तो वो था sin थीटा। तो लैब में तुमको क्या करना है? लैब में यू विल मेक यूज ऑफ अ रेक्टेंगुलर ग्लास स्लैब। ठीक है, you take a rectangular glass slab, keep it on a chart paper, then run pencil around the base of the rectangular glass slab. तो तुमको क्या मिल जाएगा यहाँ पे? ABCD
डायग्राम।
So you get the impression around the base of the rectangular glass slab. ठीक है, अब तुम क्या करो, ये साइड में दो पिन, insert 2 pins on this side, P1 and P2. ठीक है, what did you do? You inserted 2 pins on the other, like let us say I am conducting the experiment. I have kept the rectangular glass slab like this. So one face I am facing DC मेरी तरफ, so AB is on the other side. Here I am fixing 2 pins. ठीक है, now I am observing those pins from this side, right? So I'll close one eye and now I'll try to fix another pin this side such that all the pins are aligned in one line. What did I do? 2 pins I inserted here. Now I'm observing from this side with one eye closed. I'm inserting one more pin such that only this pin is visible, only one pin. That means the line of sight, all of them are in the same line of sight. and then one more pin. एक यहाँ पे कर दिया, उसके बाद और एक किया. Now I am able to see only one. So you can test it with your fingers. If with one eye closed, it is possible to only see the nearest finger. So when this happens, that means everything is in one line. You can do that, right? Lateral shift, huh? एक को fix रखो. Keep the finger away from you fixed. Now move this finger like this. And this finger only should be visible to you. So it is possible. Correct? So once you do this, so what you will observe is here. So this was the original direction. ठीक है. But actually जो तुमने यहाँ पे पिन इंसर्ट किया है, you will be surprised although you saw the pins in the same line. ठीक है. So pin निकाल के now you draw the line. जहाँ पे दो impression है pin का, here also you draw the line. ठीक है. So what you see is this, which is expected. Although you are seeing everything in one line, but when you actually completed the ray diagram, so you see that the light ray is actually traveling like this, which is expected. Because here, what was the medium here? Air. Then you have glass. Then again it is air. So this is expected. Right? So once you have this diagram ready, now you measure this angle, I and R. Let's call this I1 and R1. Now make the observation table. Serial number, angle I, angle R, sin I, sin R. Okay. So you take the first reading, you will take I1, R1, then you will have sin I1, sin R2. Okay, then you will take the ratio sin I by sin R. So you will have some value, so that will be mu 2, 1. Okay, this will be the mu 2. This is what you will get. So let us say you get some value here. Okay, so you'll get some value, right? Likewise, you can repeat the experiment by inserting the pin at a different angle now. So now you'll note down I2, R2. Then likewise you'll calculate sin I1, sin R2 through the sine table here. The table, sine table with you, right? Natural sine table. So you have to measure the angles every time and find this ratio. You will, when you repeat this experiment, you will find that this value you are getting constant for a given pair of pin. This is here class, same prism at different angles. This will be constant. And if the prism is glass, it is a glass slab using rectangular glass slab. It is called rectangular glass slab. Okay. Are you getting it? So this thing will get constant and it should be 1.5. For all readings, for all different angle of incidence and refractions, you will get sin I by sin R as constant, same value 1.5, 1.5, 1.5. Understood? So this is how it is. Now you can do this experiment in another way where you don't have to measure the angle. You can do it with the help of length of the triangle. So what you can do instead is you can draw the circle. Okay. right? So you'll have two right angle triangles. Let's call this as O. You can have E, Q, R, S. So you've got two right angle triangle. What are the triangles? PQO and triangle ORS or RS SR. You got two right angle triangles. So you don't need to measure angle I. You can directly take sin I. What is sin I? Sin I is opposite PQ by PU. And sin R will be OS, sorry, what is it? RS or SR by OS or SO. And PO is equal to SO because it is radius of the circle. Hypotenuse is same. So there are two methods by which you can find the refractive index. Either by measuring the angle or just by measuring the length. Just take the ratio. So when you take sin I by sin R, you need not even measure the PO, just you have to measure the sides. So what is sin I by sin R?
PQ by RS.
What is PQ by SR? Just by measuring these lengths, you can calculate the refractive index. Because this gets cancelled. OS and PO are equal. Being hypotenuse or radius of the circle. Clear? Okay? So you don't require even the sine table. Just by measuring the lengths, you will directly be able to calculate the refractive index. So it is that simple. Okay? सबको समझ आ गया कैसे निकालते हैं रिफ्रैक्टिव इंडेक्स लैब में? तो अभी तुम्हारे पास टेबल दिया हुआ है, बहुत सारे सब्सटेंस है, लिक्विड का कैसे निकालोगे? ग्लास तो एक सॉलिड है, टर्पेंटाइल है, केरोसिन ऑयल है, बहुत सारे लिक्विड है, उसको कैसे निकालोगे? तो ये जो रेक्टेंगुलर केस ले लोगे, उसके अंदर लिक्विड भर दो, फिर उसमें से तुम लाइट पास करके निकाल सकते हो।
अगर लाइक लैब में हम परफॉर्म कर रहे हैं, हमने रेक्टेंगुलर केस में लिक्विड लिया, तो जब उसमें से निकलेगा तो वो मीडियम भी रिफ्रैक्ट करेगा सब उसको।
कौन सा मीडियम? जो ग्लास जो कंटेनर का मीडियम है, तो कंटेनर के मीडियम में डिविएशन नहीं हो रहा, वही हमारा नेक्स्ट टॉपिक। अभी देखो यहाँ पे बेंडिंग हुई क्या? ये इंसिडेंट रे है तुम्हारा, मान लो ये इंसिडेंट रे को हमने नाम दे दिया TO, ठीक है, और ये O, इसको SQ दे दिया, SB ले दिया, UV दे दो, हाँ, XY कर दो, XY, तो TO यहाँ पे आ रहा है और XY यहाँ पे आ रहा है, so there is no deviation, जितना ये इधर बेंड हुआ, फिर से उधर अनबेंड हो गया, लेकिन अब यहाँ पे क्या आ गया? लैटरल शिफ्ट आ गया। There is only lateral shift, there is no deviation.
सर वो lateral shift
तो lateral shift से हमको कुछ नहीं फर्क पड़ेगा उससे।
बट सर जब हम इनिशियली पास कर रहे थे, तुम
जब पिन देख रहे थे तुमको सब एक लाइन में दिख रहे हैं।
नहीं सर, अभी जैसे इसमें इनिशियली जब हम पास कर रहे हैं, तब वी आर पासिंग इट थ्रू
ग्लास। तो जो बीच में है उसी का रिफ्रैक्टिव इंडेक्स बता रहा है।
जब हम कंटेनर में ऊपर तो डायरेक्ट पानी रहेगा, तो प्लेट भी रखनी पड़ेगी।
क्या?
जब हम लैब में सेटअप करेंगे लिक्विड के लिए, तो जो हम कंटेनर लेंगे फिर तो उसमें ऊपर भी लिड रखना पड़ेगा।
तो लाइट ऊपर से थोड़ी आ रही है, हम ये जैसे है, ये ऊपर ये ब्लैक है, लिड है ये, लेकिन लाइट हमारी कहाँ से आ रही है? इधर से आ रही है। ठीक है, लिड ब्लॉक नहीं करेगी, समझ गए ना? तो बेस्ट थिंग इज समटाइम्स इमेजिन करने में चैलेंज हो रहा है ना, मेक प्रॉप्स, क्राफ्ट, वो अपना क्राफ्ट का स्किल यूज करो, ठीक है? तो ऐसे ऑब्जेक्ट्स बनाओ, 3D ऑब्जेक्ट्स, या कुछ जैसे रबर है तुम्हारे पास, वो ले लो, ठीक है? तो लाइट से हमसे ऊपर से मतलब नहीं है ना, लाइट तो इसमें से निकल जाएगी। तुम्हें ये पूछना चाहिए, देखो रिफ्रैक्टिव इंडेक्स किसका निकल रहा है, जो बीच का मीडियम। अब जब तुमने कंटेनर लिया तो कंटेनर का कैसा आएगा, बॉर्डर आएगा नहीं वाला, इधर भी बॉर्डर आएगा, लेकिन यहाँ तो लेटरल शिफ्ट मिल रहा है ना, हमको लेटरल शिफ्ट से कोई मतलब ही नहीं है, वो तो डिविएशन कैंसिल हो गया, ये रिफ्रैक्शन है ही नहीं। So there is no refraction in case of light emerging from the glass slab. Wherever is the refraction is inside, not when it comes back to the same medium. समझ आया? तो हमको अंदर के मीडियम का तो रेशियो चाहिए, और ये भी पैरेलल नहीं मिलेगा ना, यहाँ पे अगर lateral shift होता भी है तो पैरेलल एंगल चेंज नहीं होता, ठीक है? So this is how we can calculate refractive index of everything. Just have the container, उसमें liquid डाल दो. So that was about lateral displacement. Yeah, that was the last topic. So lateral displacement में क्या होता है? Just the conclusion. That's it. You have to only remember this. Lateral displacement takes place without any deviation. There is no, because these are parallel rays. Deviation, there is no angle between parallel rays. Zero angle. Okay? Parallel rays में angle थोड़ी होता है, zero है. Angle तो तब होगा ना when one line is inclined with respect to other. If it is parallel, there is no deviation. Understood? And second तुम क्या देखोगे इसमें? Angle of incidence is equal to angle of emergence. The angle of emergence क्या है? ये. This is called angle of emergence. ठीक है? तो ये भी कर सकते हो. इसको sometimes you will call it R1, R2. This you may call I1. तो इसको I2 कर दोगे. This can be called I2 also. ठीक है? Either you call I2 or you call or I1 is equal to where A is called angle of emergence. ठीक है? E और लिख लो, नहीं तो E डिवाइड बाय I2 है. Okay, is that clear?
The table you made in sine R, shouldn't it be sine R1?
It should be sine R1. Next case it should be R2. This is R1, no? So it should be sine R1. Everybody, the first record is all R1, I1 R1. Next में sine I2, sine R2. That's it. You can complete it. Okay. So if you have any questions, I'll clear it next class.
अरे ठीक है ये डालेंगे
कौन सा क्वेश्चन था?
हेड पॉइंट
कल पेपर दिया था
सैटरडे संडे
लास्ट
डायग्राम
अच्छा वो पुली वाला
पुलिस वो
अरे यार,
वो सब क्वेश्चन हाँ